Hello, my name is Jeff Kuipers. I'm the Visual Effects Director at Electronic Arts. And today I'm going to talk to you about Jedi tricks for visual quality. I've been doing visual effects for AAA console games for about the last 15 years. And in this last 3 years, I've been working with Unity in mobile. And some of you may wonder why I went from AAA console to mobile. Well, there's a really good reason for that. It's because of the potential I saw there. John Riccitiello mentioned this morning how mobile has become even larger than PC or console, and this trend is expected to continue. And things just got more exciting. Less than 2 weeks ago, Google announced their Daydream announcement, and VR adoption on mobile platforms is going to be massive. There's never been a better time to become an expert in developing visual quality on mobile devices. So why is visual quality so important? Well, you stand out in a crowded market like mobile. It's your first chance to attract players to download and play, and you're more likely to get featured on an app store. I see visual quality as the first 70% is what makes you competitive. It's cohesive design, good models and readable textures for your environments, expressive character animation. That's just what makes you competitive. I'm going to be talking about that last 30%, which adds production value and makes you stand out from your competition. So Star Wars Galaxy of Heroes is a mobile collectible card role-playing game developed by Capital Games in Sacramento, California. We launched in November 2015, and we've been consistently in the top 20 grossing mobile games on both Google Play and the App Store. The art team at Capital Games really cares about Star Wars. We're all huge Star Wars geeks, and we wanted to create the highest possible quality for a Star Wars game on mobile. Here's the trailer for our game. So Galaxy of Heroes had some major challenges. Our first challenge was to take a beloved big screen film experience and translate it to a small screen. Our second challenge was to do it with the highest quality possible on a range of devices, from the newest to 4-year-old phones. So why is frame rate important? Because if the frame rate drops, it's a frustrating experience for your players. Too frustrating, and they unload your game. For mobile VR, it's even more challenging at 60 frames per second, and it's not an option to drop below 60 because your player will get sick. These frame rates aren't possible using features like real-time global illumination or lots of post-processing. On Galaxy of Hero, we made very deliberate choice for visuals that looked great on the widest range of devices. So here were some of our key approaches. We prioritize process. Process is even more important than technology and tools. We made the most of our lighting. We used visual effects to build atmosphere and excitement. And we used specialized shaders and plugins where it really counted most. So in terms of process, rapid iteration is really critical, but maybe not like this. The most overlooked way to improve your visual quality is to give an artist the ability to iterate faster. So who here thinks you could make something look better if you had 10 chances instead of 2? Yeah, definitely. A key part of VFX iteration for me was how does it look in-game? VFX, it's really important to see things in context with the environment, with the animation, and to see a full sequence from ability to impact. An engineer wrote a script for me so I could define characters on both sides of the combat and choose a battle environment, and then I could play it over and over and iterate. I also found a way to do live tuning for VFX within Unity and then save it out. Let's take a look. So what you can see here is, that's pretty dark. I'm using an asset override here so I can test a Vader ability, and I've got multiple Vaders on the enemy side. So basically what I'm doing is I'm playing the ability, then pausing the game and selecting the V effect. And then once it's selected, I can replay it over and over again. So I can see it in context. I can see it on the character, and I can see it at the right perspective from the camera. So now I'm coming in, and I'm deciding maybe a few more sparks would probably look really good. So I'm doubling the spark count. And then I can test it, and sure enough, that looks really good. And now when I play the game again, that change is in my game. And now by bringing up the name from the hierarchy in my project view, which I'll do here in a second, I can now drag and drop that prefab into my project view, and I've saved it. So the one caveat here is sometimes the game will change your transforms, so that's something that you need to adapt. Workflow improvements are extremely cost-effective. A few days of engineering time can translate to months of improved development for artists. Let's take another look. Let's take a look at another Unity trick. So another thing that I like to do was alter the time scale during in-game playback. This is really valuable for checking timing and visually debugging for visual effects especially. So what I'm doing here is I'm just typing in time in the help. It brings it up. And then now you have access to change the time scale in your in-game playback. So now I'm changing it to half speed. So when I am testing Dooku's player ability here, it gives me a chance to really look at all the elements in-game. And then I can change it back to the regular time frame. So great lighting is one of the most dramatic ways to achieve a professional-looking game. We had amazing lighting by our lighting artists, Joe Gomes and Lai Tran. We couldn't use real-time global illumination, of course, because it drops the frame rate. But you can bake lighting for a really rich look. Things to consider are using bounce lights to accentuate your areas of interest. Use as many lights as you want in your bake to get the look that you want. Remember that you're not limited by processing power, but you are limited by time. So rapid iteration here means using lower initial lighting settings while you're testing. So other tips for baking, use high res for the final bake. We used 2048, and then what we did was reduced it down to 512 for the final game. Changing scaling on your objects for your light maps is a really interesting way to get quality because you can make it higher on objects that are closer to the camera where the light map really counts and smaller for distant objects. And then we also use one light map per environment, which we shared anywhere from 2 to 4 views in our game. So that was really economical for us in terms of memory. So when you take a look at this scene, you're immediately struck by the sense of depth and distance that the fog is giving this. In real life, when we see atmosphere, it's due to particulates in between us and the thing we're looking at. Hardware fog is essentially free, and I think you're a bit crazy not to use it unless you really don't need it. Hardware fog uses the depth buffer, which is part of the rendering technology, to put layer color at a certain depth. You can tune for subtle or dramatic effects, but keep in mind that it doesn't affect your characters. So I'm going to show you how we did that in-game here. The example is tuning the fog settings in Jakku. So the first thing to do is to change your fog color to something really vivid and not in your scene at all. That really allows you to see exactly what the fog settings are doing. So you can see I'm pulling back the fog settings to a reasonable amount for this scene into the background, and then tweaking the foreground just slightly to bring it just a little bit back into the foreground area. Then changing the fog color by picking the haze in the sky, it looks really naturalistic. Usually your fog color is either the sky or your haze layer. And so you can see back and forth here how much of a difference that makes to adding atmosphere in this scene. VFX provides continuity between lighting, atmosphere, and the environments. It's really important that the lighting is finalized first so that the VFX don't have to be redone, because the VFX artist is going to be matching his VFX to the final lighting. So next I'm going to show you a breakdown of the carbonite chamber, which illustrates how lighting, fog, and VFX work together. So here you can see no lighting, and then the addition of lighting, the fog layer, and then the visual effects added to it. For our character lighting, we use light probes so that the character lighting would match our baked lighting. And we also use matte cap shaders. And we did this to add reflections to characters like Darth Vader and stormtroopers without the expense of reflection maps. Using matte caps also allows characters to pop dramatically from their background without using additional real-time lights. In the example here with the textures, more red means more reflection. So here's another example of our matte cap shaders. The matte cap texture is changing, so does the reflective properties of Vader's outfit. You can see them changing here. And then the dual texture affects the rim lighting. And different rim light textures and different levels of brightness really impact the look. You can really create a wide range of different looks really cheaply this way. So VFX can add visual excitement, tie the character and the environments together, make the gameplay feel more responsive and immersive, and deliver really satisfying playoffs for your player. The more atmospheric and action-packed your game is, the more VFX you're going to need. I'm going to show you my layered VFX approach with this Jawa muzzle flash. So why multiple layer elements? It tends to make the effect look more rich and more random. Humans are great at pattern recognition. Texture sequences get boring after probably the third time you've seen it. Building variation from modular parts makes a lot more sense and delivers more randomness. So here you can see sparks, smoke, a flash, and the fireball all acting together. And each time it plays, it'll play differently. Obviously, this is captured, so it's looping. I find that fewer high-res textures that are shared between all of my effects gives a lot better quality and much more variety within a constrained memory footprint. Often the use of specialized geometry and shaders can augment or even provide better solutions than the use of particles alone. So here we see a crashed snowspeeder, and this is the typical way I would approach some smoke with particles on it. So the thing to notice here is that with how bad the overdraw is, especially at the root of the smoke column, which is just a typical problem with VFX particle-rendered smoke columns. So we took another approach. We used a UV distortion shader on a single quad, which was great in terms of overdraw. And it also gave us the flexibility to stylize our smoke and use it for a lot of different options. We actually use this variations of this shader all throughout our environments. Optical and volumetric effects massively enhance your visual quality. Simulating that on mobile is really expensive. So this is a really simple but powerful alternative. You can see here I've got a flare effect, and it's centered on the object. The problem is it's cutting through the geometry and doesn't look convincing at all. By contrast, using a pull-to-camera shader, it's a really convincing optical effect. So how does that work? So the billboard remains centered on the geometry, say a prop or a character, but it renders in front of the object regardless of the camera position because it's being pulled to the camera in Z space when it's rendering. This is an extremely effective way to do lighting and volumetric effects. So it doesn't matter how great your effect looks if it negatively impacts performance. And the number one way to optimize is to reduce overdraw. The problem is that you can't view overdraw mode in game view. But by matching your scene view to your game camera, you can make use of this valuable tool. So here's an example. So what you do here is you type in the hierarchy, you type in camera, and select your game camera. And then you select Align View to Selected from the menu, and you'll see the scene view snap to the camera view. So now, the overdraw option becomes more meaningful. So now I'm turning on overdraw in the scene view, and when I test my effect, I can actually see what the overdraw is doing, which makes it extremely useful to see it from the camera view. So other optimizing strategies for particles specifically is varying start times, randomizing your lifetimes, reducing size of particles over time for stuff like debris and sparks, and killing off particles as quickly as possible for each layer. For the final part of my talk, I'm going to take you step by step through the development of lightsaber strike VFX and how we achieved an authentic Star Wars feel. So the first thing that was really important was considering reference. I think valuable reference to a VFX artist is similar to good character reference for an animator. You pick up subtleties, secondary animation that you just wouldn't think of if you were dreaming it up off the top of your head. All the reference here is showing lightsaber strikes, and you can see how visceral this is. The Star Wars VFX are rooted in practical effects. So there's lots of explosive charges, smoke, sparks, and these were visuals that we wanted to carry into the game. All right, so what I'm showing you here is this is the lightsaber blade VFX, and this was done really quite simply with two overlapping stretched particles with a core inside glow and an outside glow that were respawning for a really energetic feel. You can see how it works from almost any angle. We used prefab evolution to make a master V effect for the lightsabers, and then had variations of colors for different characters. The really valuable thing about that is that you can make changes to the master in terms of the overall look that carries through to all the instances, but the instances still retain their individual color attributes. The trail effect was essential to the lightsaber look and really emphasized the animation. So you can see the trail geometry on the left and the in-game on the right. You can see how the impact gives the lightsaber the sense of power. And just like you saw from the reference, the sparks were especially important. Play that again. A lot of times VFX artists will just create like a motion blurred spark and forget that having a few sparks that remain jagged really adds to a sense of like organicness and makes it just feel more realistic. Also, our pull-to-camera shader was really important from keeping our flashes intersecting through the ground plane and also sorting in front of the character. All right, I've really enjoyed sharing an inside look into Galaxy of Heroes art production with you. I would say the take-home message is the mobile space is really exciting and getting even more so. It's challenging, but it is possible to create great-looking visuals without using post-processing or other expensive techniques. The Galaxy of Heroes team found creative ways to make great visuals, and so can you. I hope this inspires you to find your own Jedi tricks for visual quality. And please come find me if you want to talk to me about anything I've shared. Thank you.